Today we're going to review adding and subtracting fractions. This is a skill you should have worked on in 5th grade, so we are just kind of reviewing it today so that it can lead into our next operations of multiplying and dividing. There is one big thing you have to do in order to add and subtract your fractions, and that's step 1 right here. And step 1 is to always check the denominator. Which is that number on the bottom. If the denominators are the same, you can just add the numerators and move about the problem. When they're not the same is when you get to do a little extra work. So that's going to be step 2. If denominators are not the same, you will need to multiply and divide to create equivalent fractions. So multiply or divide because you have to have a common denominator in order for the problem to work. Step number 3 is super duper important. When we were creating equivalent fractions yesterday, we talked about how you always have to multiply the bottom and the top by the same number because it's like multiplying by 1. So right here, whatever you do to the bottom, you must also do to the top. So we have to change them equally. Then you're going to add or subtract just the numerators, and you're going to always keep the denominator the same. Okay? The denominator is consistent through the whole problem. And then step 5 is going to be simplify when possible. So this is where you're going to divide it down into the smallest possible numbers. Over here, we give you a nice little reminder that you must always have a common denominator when you're going to add and subtract your fractions. That's the only way for it to work. Let's do some practice. So our first question right here, I'm going to number them since they're not numbered. Question 1 right here, we have 5 6 plus 2 9s. Step 1 said to check the denominators. 6 and 9 are different, so we cannot add them yet. So we need a common denominator. There are actually quite a few common denominators for 6 and 9, but I always just multiply them by each other. So what I mean by that is fraction number 1 right here ends in a 6. So I'm going to multiply the second fraction by 6's, and then multiply my first fraction by the 9's. And again, whatever I do to the bottom, I have to do to the top. This gives me 5 times 9 is 45, and 6 times 9 is 54, plus 2 times 6 is 12, and 9 times 6 is still 54. From here, we just add those numerators. So 45 times 12 is 57, and we leave the denominator the same. To simplify, this is an improper fraction, so we need to see how many 54s we can take out of 57, and that is 1, which leaves us with 3 over 54. Now, there is one more step to simplifying this problem. 3 and 54 can both be divided by 3 to get 1 and 1/18. So that's fully simplified. If you are sitting in class right now and you're like, okay, I got to this step right here of adding, you're in a perfect spot for today. So if you are not great at simplifying all the way down, we'll keep working on it, and that's okay. But we do need you to be able to add the numerators and find that common denominator. So if you can do that step, you're good enough for today. Question 2 right here. When you check those denominators, they're different. So I'm going to do the same process. I'm going to multiply my second fraction by the denominator of fraction 1. And I'm going to multiply fraction 1 by the denominator from fraction 2. So 4 times 2 is 8, and 4 times 7 is 28. 7 times 1 is 7, and 4 times 7 is 28. And then we're just going to add them up. So when I say just add them up, do I add the numerators? Yes, 8 plus 7 is 15. But do I also add the denominators? No, we keep them the same. From here, we kind of ask ourselves, can we divide 15 and 28 by anything to simplify them? And the answer to that is no. So this problem is completely done. Alrighty, something has changed from from question 2 to question 3. And that is that now we're going to subtract. So you always have to pay attention to that symbol in the middle to make sure you're doing the right thing. We still need the common denominators. So we're going to multiply fraction 2 by the denominator from fraction 1, and then repeat on the other side. So 7 times 3 is 21, and 3 times 8 is 24. And then we're subtracting, so we got to make sure we write a subtraction sign. 8 times 2 is 16, and 3 times 8 is still 24. Just like above, we're going to subtract the numerators. So 21 minus 16 is 5. But do we subtract the denominators? No, we do not. We leave that 24. And we have to ask ourselves, can 5 over 24 be simplified? And the answer to that is no. So we are finished with this problem. What happened to this last one? Okay, this last one gets crazy because now it's mixed numbers. So kind of where we started with our day-to-day, we are going to have to make these mixed numbers into improper fractions, and then find a common denominator, and then subtract, and then simplify. So a whole lot is going on here in problem number 4. So what we're going to do is start by making them into improper fractions. So to do that, we're still going to multiply the denominator by the whole number, and then add that numerator in. So 9 times 5 is 45. 45 plus 1 is 46. And then we keep that denominator of 5. Then we're going to keep our subtraction sign. Repeat over here. 6 times 5 is 30. 30 plus 4 is 34. And then we're going to keep that denominator the same. Okay, now we still need our common denominator. So to find our common denominator, we are going to multiply this fraction by 5. We're going to multiply this fraction by 6. You should be thinking, oh my goodness, we're going to get some really big numbers on this problem. And that's because we are. Usually, we will not give you numbers this big. We just want you to recognize that it can happen, and you still just have to do the math accordingly. So 46 times 6 is 276, and 6 times 5 is 30. Take away 34 times 5 is 170 over 30. So I did that multiplication for you guys just to kind of speed us up, but when we do our practice, you have to do it on your own. And now we subtract. So 276 minus 170 equals 106 over 30. We can't leave it improper, so now I have to make it into a mixed number. So the question is, how many 30s can go into 106? So I'm going to jump up here and do some division really fast. 30 can't go into 1, and it can't go into 10. But it can go into 106 3 times, and then we're left with 16. So our answer here is 3 wholes and 16 over 30. We're still not done. We still have to simplify that fraction on the end. So 16 and 30 can both be divided by 2. So we keep our whole number. 16 divided by 2 is 8, and 30 divided by 2 is 15. And phew, we are finally done. If number 4 was too challenging for you, please don't stress. That's okay. We're going to keep practicing problems like number 4. What we do need you to be comfortable with are questions 1, 2, and 3. So if you're not super confident in those yet, that's okay. We're going to keep practicing. And a reminder, you can always whisper to someone around you if they're doing a little bit better with mastering the skill the first try. Your time is now going to be left to practice.